All right, this is pre-cal academic, November 30th. Cool. All right, so solve no calculator. Solve no calculator. So the way this works is, I think, let me check to see how Miss White did it, but I think I know how I'm supposed to do these. Just says the answer. Okay. So here's how this works. So for this, for like 2 to the x equals 8, there's a couple ways we can do this, okay? You can think of it one way. Here's one way you can think of it. 8 is equal to what? 2 to the power of what? So you can rewrite this as 2 to the x equals 2 cubed, okay? If you have an equation with two bases, two identical bases, that's what I mean by 2. I'll highlight this 2. Then the exponents have to be equal. So you get x equals 3 from that. Okay? That's one way of doing it. You see that? Okay. Another way is we can try to, man, I got to break the x out of the exponent. What can I do? I got to break the x out of the exponent. If only I could cancel that 2 with something. So I can do log base 2 of 2 equals log base 2 of 8. You can also just take the log of both sides, okay? On the left, that would cancel. We get x equals log base 2 of 8. Okay? All right, and then it's just a matter of evaluating this logarithm. That would be 2 to the what equals 8? 3. I guess that kind of just gives us original problem back, though, if we do it that way. So I would say the best way to do it is to make sure the bases are the same. Okay. All right. Good stuff. Good stuff. Okay. Can I move on to that second one? Move on to that second one there. Okay. So first we want to get the 4 to the x, we want to get x by itself, right? We're solving for x. Don't reinvent the wheel. We just need to get x by itself, okay? The first thing we want to do is we want to get the exponent, like this 4 to the x by itself, okay? Before we're ready to break x out of the exponent of 4, we got to get the 4 to the x by itself, okay? Does that make sense? So how do we do that here? We have to get rid of this 3. It's a 3 times. How do we undo it 3 times? Divide. So we're going to divide both sides by 3. 4 to the x equals 16, right? So at this point, you might just be able to see that x equals 2, because right, you might ask yourself 4 to the y equals 16. Another way of doing it, you can think 16 equals 4 squared. Okay? Right? The bases are the same, so the exponents have to be equal, okay? X equals 2. All right? You see that? Four to the x equals 8. How do we do this one? Anyone have an idea? So you want to keep doing what we've been doing, okay? So here, we want to get the 4 to the x by itself, which it already is, okay? All right? And then we've been doing what? We've been making sure what are the same? The bases, right? Okay? So let's try to get it to these bases. So 4 and 8, right? They're both powers of what number? 2, yeah? So we're going to rewrite this 4 as 2 squared. So we have 2 squared to the x. What's 8? 2 cubed, okay? All right. What's my exponent rule for an exponent raised to an exponent? I'm multiplying, right? So this is 2 to the 2x equals 2 cubed. Now what equation can we write down? The bases are the same, so the exponents have to be equal. So 2x equals 3, all right, or x equals 3 halves, right? There you go. There you go. Okay. We feeling okay about that? So try to get the bases. So get the exponent part by itself. Get the 4 to the x by itself. Then try to make the bases equal. Okay. Okay, can I move on to D? So I want to get what by itself first?
Divide by 3.
4 to the 2x by itself, right? So I have to do what?
Divide by 3.
Divide by 3. Four to the 2x equals 32. Okay. 4 and 32 are both powers of what number? 2. Wow. So we're going to rewrite 4 as 2 squared. Rewrite 32 as 2 to the 5th. Okay. Those exponents here on the left do what? They multiply together, so we have 2 to the 4x equals 2 to the 5th. Good. The bases are the same, so what has to be equal? The exponents. So 4x equals 5, or x equals 5/4. All right, do you guys see that? Cool. Can I move on? Okay, so we got to get what by itself first here? The 5 to the x over 3, right? Okay, how do we do that? Divide by 2. We get 5 to the x over 3 equals 125, okay? 5 and 125 are both powers of what? 5, yep. So 5 is we just leave it. And then 5 cubed equals 125. So we'll write this 5 cubed. Good. The bases are equal. Oh gosh. The bases are equal. So the exponents have to be equal. X over 3 equals 3, or x equals 9. X equals 9. Okay, F should be like clockwork at this point. I gotta get what by itself first? Yeah, I gotta get that by itself, so I divide by 2. Okay, 9 and 27 are both powers of what? 3. So we're gonna rewrite 9 as 3 squared to the x plus 3 equals 3 cubed. Okay, what do these two exponents do? Multiply, okay, so we get 3 to the 2x plus 6 equals 3 cubed. Okay, the bases are the same, right? So my exponents have to be equal. So 2x plus 6 equals 3. 2x equals negative 3. X equals negative 3 halves. Yeah, you go. Okay. For G, okay. What can we do for G? So we want to get what by itself first? The number that has x in it, right? The term that has the exponent number thing. Yes, we're going to divide by 36. So 1/2 to the x over 4 equals, it's 1/4, right? Okay, this one gets a little weird. It's not too bad though. 1/4 is the power of what? So 4 is the power of what? 2, yeah. So what I'm going to do is, I'm going to rewrite this as 1/2 to the x over 4 equals 1 over 2 squared, right? Okay? 1 over 2 squared is the same thing as just 1/2 squared, right? Okay. That's just a thing. Okay, now what do I have that are equal to each other? The bases are equal, so the exponents have to be equal, okay? X over 4 equals 2, or x equals 8. Okay? So some of these, right, these aren't all just going to be rewriting integers as powers of another integer. Some of them will be rewriting fractions as powers of another fraction, okay? All right? You guys will figure it out. You guys will kill it. You guys will crush it. Okay? Can I go over H? We want to get what by itself? 1/3 of the x, right? So we got to divide by 27 on both sides. Nine. You read my mind. Good. 1/3 of the x equals 9. Okay. I gotta get the bases equal, right? 9 would be equal to 1/3 to the what? If I raise 1/3, right? If I take 1/3, right? I want to, or if I take 9, sorry. If I take 9, right? If I bring it down to the bottom of its fraction, makes it 1/9. So that'd be 1/9 to the -1. Okay? And then if I make this into a 3, right? The 1/3 to the -2. Okay? So 9 is equal to 1/3 to the -2. Good. Can we put it away, please? All right. So we have the bases are equal. They're both 1/3. So the exponents have to be equal. So x equals -2. Okay. So you got to be a little more clever on that one, right? You're just looking for, when you have a fraction and an integer, what you're looking for is like a denominator, or that is like. What's what am I trying to say? I'm looking for like an integer that's a power of the denominator over there. Okay. All right. Can I do I? So I get what by itself? Yeah, this part. The 2 to the x over 5. Okay. I do that. I'm going to do that by multiplying by 8 on both sides. Good. 64 is the power of what number? 2. 2 to the what equals 64? Yeah. Yeah. So then the bases are equal, so the exponents must also be equal. X equals 30. 30. That's what I got. Yep, that's what I got too. Can I move on? This one right here, J. I feel like this is kind of like from the last lesson, don't we? This is the same as what? Log base 7 of 49. That's the same as asking ourselves what? You don't multiply 7. Log base 7 of 49. To evaluate that in your head, you ask yourself what? 7 to the what equals 49, right? 2. That make sense?
Yeah.
Okay. So that evaluates to 2. What? Oh, you're good. Okay. Yeah, can we go out in K? K, right, we got to break X outside of the logarithm. Right? We got to break X outside of the logarithm. How do I do that? What's that? Out of 10? Or you're on the right track though. 2. It's the same as whatever the base of the logarithm is. So the two sides of this equation are equal. So 2 to the left side has to equal 2 to the right side. So we're going backwards, right? Before we said, hey, we have the same base, so the exponents must be equal. Now we're saying, hey, these two numbers are equal, so we can put in whatever base we want on both sides, okay? 2 to the log base 2 of x does what? What happens? That cancels, right? So we get x equals 2 to the 3rd, or 8. Okay. 8. Can we move on to the next one? L. We gotta break. We have x plus 2 inside. Now we just gotta break everything out. How do we break it out of the log? 4. Yeah. We raise both sides to the 4. Is that what you're saying? Yeah. So right, we gotta cancel out this logarithm. So 4 raised to the left side equals 4 raised to the right side. If we want to cancel both sides, right? That cancels here. Now we got that out. X plus 2 equals 4 squared. Or x plus 2 equals 16, or x equals 14. We feel okay about this? It's not too hard. All right. Okay, move on to M. All right, Alberto. Let's have Alberto take a shot at this. Okay, I got to solve for x. You just got to get x by itself. We got to break it out of that log. How do we do that?
You just make it like use like.
Yeah. 3 to the left equals 3 to the right. What is that? What happens on the left then, Alberto? Right here.
Well, you drop down the 1 minus x.
Yeah, so that cancels. 1 minus x drops down. 9. I think we're on the right track. So then we get 1 equals 9 plus x, or x equals negative 8, right? Okay. We following this? Okay. I think it's not too bad. Good stuff. Part N, we want to get what by itself first? So we want to get the log, just like we were getting the exponents by themselves, now we want to get the logs by themselves. We're going to divide by 2. Well, okay, how do we break everything out of the log? 4 to the left equals 4 to the right, right? That cancels. We have x plus 1 equals 4 squared, or x plus 1 equals 16, or x equals 15. Okay. We want to get what by itself first? We want to get the log by itself, so we need to subtract 6.
You do 5 first and then subtract.
It'd be kind of a bear, but you can do it. I recommend against it. Now we can divide, right? Now we divide by -3. Now we're ready to do what, Jade?
Sorry. You do 6 squared equals to 4 plus x.
Yeah, so we're going to raise both sides. 6 raised to the left equals 6 raised to the right. These cancel. We have 4 plus x equals 6 squared, or 4 plus x equals 36, or x equals 32. Okay. Yeah, you can. Yeah. Are you guys okay if I move on? Solve, use calc. I think by calc she means calculator, not calculus. Cool. So we got to get x by itself, right? So we got to get what by itself first? The exponents. So we'll divide both sides by 6. It's not that way. She means like using logarithms on your calculator, not by graphing. Yeah. So we got to break the x out. You guys know how to do this, though. How do we do that? We break an x out of a log by doing an exponential. So we break an x out of an exponential by doing log, right? So what cancels with the 2? Log base 2. If we do log base 2 of the left side, that equals log base 2 of the right side. Okay, those will cancel, okay? So you break x out of logs by doing like the exponential of both sides. You break x's out of exponents by taking the log of both sides. Like they undo each other. Does that make sense? They undo each other. So we have x plus 1 equals log base 2 of 3, or x equals log base 2 of 3 minus 1, okay? That's where you have to use your calculator, okay? This becomes x equals log 3 over log 2, right? We have to use change of base. I use that. All right. So log 3, you should know how to do this with your calculator. Log 3 divided by log 2 minus 1. So 0.584, say 585. Is anyone having trouble doing logs on their calculator? This one, can I move on? I gotta go up by itself first. The exponent, right? So I'm gonna divide by 17 on both sides. That gives me a wonky. That's in simplest form. How do I break that x out of the exponent? Yeah, yep. So you take the log of both sides and you make the base of the log the same as the base of the exponential. So these two should match, okay? And again, most people will write it ln e to the x equals ln 93/17. These cancel, so you have x equals, and then natural log of 93/17. Are you guys okay, comfortable? Are you comfortable doing that by yourself on your calculator? Take that as a yes. So I got 1.699. What you guys got? It's pretty close to 1.7. If I move on.
There's the restroom.
Yes.
What'd you get on
1.699. Okay. Here, right, same thing. We want to get just the exponent part by itself. So we divide both sides by 50. Okay. Now I do what to both sides to break that x out of my exponential? We'll take the log, right? What's the base of my log? It's the same as this base here. So I'm going to do ln of both sides. So I get negative 0.112x equals ln 4, or x equals ln 4 over negative 0.112. Okay, are you guys okay doing that in your calculator? Okay, if I move on, I want to get just this part by itself. Okay, a couple more seconds. I'm going to move on to D. Alright, I gotta get the 1.73 to the x by itself first. So I do what? Divide by 3. How do I break that x outside of the exponent? Do what? Log, yeah. So it needs, what's the base of the log? Nope, not 10. It's the same as the base of this exponent here. So it's a log base 1.73 of x equals log base 1.73 with 3.24. These cancel, we get x equals log base 1.73 with 3.2. Okay? How do I put this in my calculator? What do I have to do? Yeah, so I use change of base. Log base 10 at 3.24 over log base 10 of 1.73. So that gives us that. I got, oh, that's right. 2.1147. Oh. Did I write it wrong? Oh, sorry, it's 1447. Sorry about that. Alright, this E here. Right, we gotta get just the part with the exponent by itself first, so we're gonna divide by 81 on both sides. So we have e to the 4x plus 1 equals 200 divided by 81. That's already in simplest form. Okay. How do we break the 4x plus 1 out? Yeah, take the log base e of both sides. So we get 4x plus 1 equals ln 200 over 81. Okay, and then we just gotta solve for x. So I'll just have to plug this into my calculator. Are you guys comfortable doing that? You want me to show you that? Okay. So I'm going to do, the way I'm going to do it, I'm going to do log ln of 200 divided by 81. Close my parentheses, that was a minus 1 on top, right? Or minus 4? Minus 1. Then I'll do minus 1, I'll do all that at once, I'll hit enter. And then I'll do divide by 4. It's important that you hit enter so that your calculator does the order of operations correctly. Okay? If I type divided by 4 on this first line, it would have seen this as natural log minus 1/4. We want it to do minus 1, then divide by 4. So negative 0.0240. You could. You have to make sure you do it correctly, though. Missed out. Okay, I want to get in the 3 me on part F, I got to get just the exponential part by itself, right? So I'm going to subtract 10. Divide by 5. How do I break the x out? Log base 3 of both sides. Okay. So I get 8 equals log base 3 of 38. How do I rewrite this before I can put it in my calculator? Yeah, so I'm going to do log 38 over log 3. And change of base. It gives me 3.3, 1, 1, 1. I'm building it, so see you later. Hells. Yeah. I hate doing that too. But yeah, you got it. So that's my x. I should write x equals. Can I move on? Got these problems. So we're still solving for x, okay? Don't reinvent the wheel. This is probably gonna be a combo, okay? So I gotta get whenever you see one of these, think you gotta get just the log by itself. A single log by itself. We already have a single log. Okay. So I'm gonna subtract 3. Okay, divide by this -2 to get rid of that. How do we break an x out of a log? I said what? You do the opposite, right? So an exponential breaks it out of a, I just said the answer. So a log breaks it out of an exponential breaks it out of a log. So how do I break x out of a log? Yeah, so 6 to the left equals 6 raised to the right. That cancels with that. The 6 cancels with the log 6. I have x plus 2 equals 6 to the -1. X plus 2 equals 1/6. X equals 1/6 minus 2. Which is equal to -11 over 6. Okay. Let's do this one. Can I do B? So we want to get one log by itself. We want to get the log that contains x by itself. So let's add 2 to both sides. Okay. Now at this point, I'm going to divide by 3. And how do I break x out of a log? I do what? Left side? Be x equals what? We undo logs with what? Yeah. E to the left equals e to the right. We undo logs with exponents, we undo exponents with logs, okay? So e to the ln x, do you see how these cancel? x equals e squared. All right, x equals e squared. Okay, let's do, I'll whip through, let me do one of these harder ones. I'm going to have you do the homework for next time, so let me do a harder one. Here's a good one. So what we want to do here is we want to combine everything into a single logarithm. So I'm going to get all my logs on the same side of the equal sign. Okay, let's combine these using the division rule. Combine these with the division rule. Okay. Then 7 to the left equals 7 to the right. Okay, that cancels. 7 to the 0 is what? 7 to the 0 is 1. Okay. 2x equals 15. X equals 15 over 2. Okay. 5.5 home for next time. I'll finish up these last few examples. We'll talk about the homework, and then we'll jump into the quiz, okay? Good work today, guys.